This lesson is on reducing, multiplying, and dividing rational expressions. So first let's discuss what a rational expression is. A rational expression is the quotient of two polynomials like p of x over q of x. So some examples are, we have a polynomial up here on the top, y squared minus 3y over 10 over y squared plus 2y minus 35. Even 7/9, some students might not think 7/9 is a polynomial, but 7, even though it's a number, it classifies as a polynomial. And even the last one, where we have a monomial over a monomial is a subcategory of polynomial, so this all works. So when reducing rational expressions, you can only reduce when there is a common factor in both the numerator and the denominator. Then these factors can divide to 1 or cancel out. I don't really like using the word cancel. I prefer dividing to 1. So to find the common factors, you must factor first. This is so important, okay? So for the steps, we have 2 steps. I want you to factor the numerator and the denominator, and then divide out any common factors. We'll first start with 24/9. Now, one way of reducing 24/9 is to rewrite it as a product, the numerator and the denominator as a product, or factoring the 24. So 24 can be rewritten as a factor 3 times 8. So 3 is a factor, 8 is a factor. And 9 can be rewritten as 3 times 3. So what do you notice in the numerator and the denominator? Well, the 3's divide out, and you're left with 8/3. 8 can factor more. 8 is 2 times 2 times 2, but the 2's in the numerator and the 3's in the denominator don't actually reduce out, so 8/3 is as reduced as possible. On the next problem, notice it's already factored out. So there is already a multiply sign in the numerator and a multiply sign in the denominator. Because there is a multiply sign between the two parentheses, that means I can simply divide out any common factors, the entire parentheses x plus 3 and the entire parentheses x plus 3 in the numerator and denominator, divide out, and I'm just left with x minus 4 over x minus 2. That is my final answer. You can put parentheses around the numerator and denominator, or you actually don't really have to. Either way is fine by me. Let me just remind you of a common student mistake. Some students will take x minus 4 over x minus 2, and then they'll say, oh look, this x right here and this x right here, they're common factors. Let's divide them out and then just get negative 4 over negative 2, and then usually they'll even reduce it again to get positive 2. This is wrong, okay? Wrong, wrong, wrong. You are not allowed to divide those two x's out because you didn't do the first step first, which is factor. So if I have x minus 4 over x minus 2, those don't factor at all. This minus sign right here tells you that the x and the 4 are being subtracted. Now the opposite of subtract is not divide. So I can't take that subtract and this divide and say they're opposites. They aren't, okay? You're not allowed to do that. So that means your final answer has to say x minus 4 over x minus 2. If it helps you if you are thinking, oh, I want to divide those, maybe you should consider putting parentheses around the top and parentheses around your bottom, reminding you that that x and that minus 4 are stuck together. That little minus sticks the x and the 4 together like glue, okay? They have to divide out together or not at all. So let's reduce the following rational expressions. Step 1 says I have to factor first. So I'm going to take the numerator and factor it, and take the denominator and factor it. So I have no GCF in the numerator. It's a 3-term polynomial, and the leading coefficient is 1, which means I'm just going to find two numbers that multiply to negative 10 and add to 3. I think those answers are 5 and 2, with one of each sign. To get to a negative 3, I'm going to put a negative 5 and a positive 2. On the denominator, again, there is no GCF. There are 3 terms, which means it's a trinomial. It's an easy trinomial because the leading coefficient is 1. So again, I'm looking for 2 numbers that multiply to 35, yet add to positive 2 with 1 of each sign. I think that's a 5 and a 7. To get to a positive 2, I think it's a plus 7 and a minus 5. Step 1 is done. I have completely factored. And what I've done is I've turned these pluses and minuses in the polynomial into a product. So this was a polynomial. Now it is a product of polynomials. Because it's a product and it's multiply, the opposite of multiply is divide. So I can divide out an entire parentheses with entire parentheses in the denominator if they're exactly the same. In this case, the y minus 5 and the y minus 5 are exactly the same. And so my final answer is y plus 2 over y plus 7. So here's a question. Can I divide out those y's? No, you cannot divide out those y's because this is a plus sign. The opposite of plus is not divide. If you think you might want to factor or divide those y's out, put the parentheses around it to remind you that they're stuck together. They're like a little factor family. You can't break up those y plus 2. Okay, the plus and the minus is like glue. It sticks them together. On the next problem, we have no GCF in the top. There's no GCF in the bottom, so we can go ahead and start factoring. The numerator looks like it's a sum of cubes. 2x quantity cubed plus 3 cubed. And so I have in my binomial 2x plus 3. In my trinomial, we have 2x times itself 2x. That's 4x squared. The last one's 3 times 3 or 9. And the one in the middle is a little compromise, 1 of each. My signs are same, opposite, always positive. On the denominator that also doesn't have a GCF, this is a 3-term polynomial. It's a trinomial with leading coefficient not equal to 1. I choose guess and check. You could also do the AC method if you wanted. So I'm going to do 1x times 2x, 1 times 9, or 3 times 3. So in my guess and check method, I'm going to put the 1 and the 2 vertically, the 3 and the 3 vertically, and then I'm going to cross multiply to see if I can get that middle product. So that gets me 6x and 3x. Can I use 6x and 3x with 1 of each sign to get to negative 3x? And the answer is yes. So a minus on the 6, a plus on the 3. So that gets me x minus 3 and 2x plus 3. Once I have it factored and there's multiply signs between my parentheses, you don't actually have to write them, but you do know that 2 parentheses next to each other means multiply. So because it says multiply there, I know I can do the opposite, which is divide. So these 2 divide out to 1. Anything in the numerator and denominator that are exactly the same, divide out to 1. And my result is 4x squared minus 6x plus 9 over x minus 3. Now you might be tempted to try to factor that numerator some more, but it won't. The trinomial of a sum or difference of cubes won't ever factor anymore unless there's a GCF, which we already checked to see if there's a GCF, so this must be my final answer. On the next problem, notice that this does not have any pluses or minuses in the numerator or the denominator. This is a monomial over a monomial. So I can't actually factor this. This one's a little bit easy. It's very similar to when we were doing exponent rules because there is no plus or minus. So I just wanted to remind you that these are a polynomial over polynomial. They don't factor, so you're just going to reduce anything in the numerator and anything in the denominator exactly the same. So 8 over negative 2, you can reduce that to negative 4 if you want, or if you want to think about it as 2 times 4, and then the 2's divide out, you'll still get negative 4. Either way you want to think about it. We have an x in the top and 3 x's in the bottom. So after you divide those out, you have 2 x's left in the denominator. My y's, I have 5 y's in the numerator, 4 y's in the denominator. After I divide, I'm going to subtract my exponents, and I'm left with 1 y in the numerator. And then with my z's, I have 3 z's on the numerator and 1z in the denominator. When I divide those out, I have 2 left, and that's in the numerator. No factoring for that one. On the next problem, we have a polynomial at the top and a polynomial in the bottom. First thing I always try when I'm factoring is GCF, so let's see if there is a GCF. Okay, yes, there is 2 in the numerator, x as well, and y. That leaves me with x minus 7, no, just x minus 7. On the denominator, I have a GCF of x, y, which leaves me with x plus 3y. Now, is there anything that's in the numerator and the denominator that's exactly the same? Some students might point out, hey, the 2 parentheses aren't the same, I can't do anything. But don't forget that the GCFs are also being multiplied. So it looks like this x can divide out with that x, the y can divide out with that y, and I have left 2 times x minus 7 over x plus 3y. Now, some students are going to ask me at this point, do I have to distribute the 2 that make 2x minus 14 in the numerator over x plus 3y? You could, and that's totally acceptable answer. I just spent several minutes of my life factoring, so it kind of breaks my heart to distribute at this point. It's not wrong, it's an okay answer, but I would probably prefer to leave it in the factored form. And that's just one less step to make an error on.